This is a video for index laws multiplication. Before we start, it's really important that we make sure that we have a good understanding of exactly what an index form is. And so if you have a look at what I've got written down here, you can see that we've got x, and we know that x is just x to the power of 1. And that's the same over here with 2. That's just the same as 2 to the power of 1. And if we have x times x, or 2 times 2, then we have x to the power of 2, or sometimes called x squared, or we have 2 squared. If we have x multiplied by itself 3 times, then we have x to the power of 3. If we have 2 multiplied by itself 3 times, then we have 2 to the power of 3. X multiplied by itself 4 times, x to the power of 4. 2 multiplied by itself 4 times, 2 to the power of 4. If you have 2 multiplied by itself 1,000,000 times, then it would be 2 to the power of 1,000,000. So it's really important that we understand that. The next thing we need to do is understand a few things about an index. So we have a base, and for this one, okay, x is our base. For this one, 2 is our base. And this is really important for index laws because we need to make sure that when we're applying our index laws that we are applying it only to those numbers or indices which have the same base. And these numbers here and here, they are called the index, and hence how we call it index laws. So let's have a look at how that works out. Okay, so the way that we need to approach this is first by thinking about, okay, we've got an expression, and our expression says that we've got x squared multiplied by x cubed. And we want to know what that is in a simplified version. So one of the things that we could do is expand both of those out. So we have x times x, and that's our x squared component of that expression. And we have our x times x, which is our x cubed component from over here. So that leaves us with the result of x to the power of 5. If we do that numerically with a new number as the base, and so we have 2 to the power of 2 times 2 to the power of 4, we could write that in expanded form first. 2 to the power of 2, which is just 2 times 2, and 2 to the power of 4, which is 2 times 2 times 2 times 2. And that would give us 2 to the power of 6. Okay, we know this because from the previous slide, we've seen that when we have 2 multiplied by itself 6 times, then we end up with the base will be 2 and our index will be 6. So it's really important to remember the base tells you, the base is the number, or in this case a pronumeral, and the index tells you how many times that number or pronumeral is multiplied by itself. One of the really important things that we want to do in mathematics is find relationships that enable us to solve problems quickly. So we've got the expression x squared times x cubed, and the result is x to the power of 5. So what's the relationship? Can we find a relationship between our expression and our simplified expression? And it's pretty easy. 2 and 3, if we add them together, we get x to the power of 5. If we have 2 and 4, add them together, we get 6. So in generalized form, and the reason why we use a general is so that we can use this as a rule for any indices, is that when you have 2 indices with the same base, then you can add their powers. Now, really important that we remember this only applies when they have the same base. So if they don't have the same base, you can't use these laws. Alright, this is where I'm going to show you a few examples, and just really important that you're paying attention. So in the first one, A, we've got 5 to the power of 8 times 5 to the power of 3, remembering that our index law is that we add the powers so long as they have the same base. So the first thing we need to do is check to make sure they've got the same base, which they do. Then we can just simply add the powers. 8 plus 3 is 5 to the power 11. Now if we were to give that out in its evaluation, then it would be that number there, and you can just find that in your calculator. Part B, again the same thing, remembering that we're multiplying two indices with the same base, so we can simply add the powers, and that gives us a result of b to the power of 13. Okay, question C is a really important one, and it's important that we realise that we can't actually apply the index law here, because we've got a base of C and we've got a base of B. They're not the same, and so we can't apply the index law. So the only way we could simplify this expression is by writing it c to the power of 4 b squared. Alright, D. Alright, in D we've got 3 to the power of 2, and we've got 3, and this is essentially 3 to the power of 1. So we've got 3 to the power of 2 and 3 to the power of 1. We can multiply those indices, and we've got d to the power of 3 and d to the power of 4. So we can add those indices as well. So we get 3 to the power of 2 plus 1, and d to the power of 4 plus 3. And our solution to that problem is 3 to the power of 3 times 3d to the power of 7. And then you'd need to simplify that and write 27 d to the power of 7. Okay, this is an opportunity for you to do this with me, just to make sure that you've got a good grasp on the concepts that we've just learnt. So for the first one, have a go at that. Alright, 6 to the power of 3 plus 6 times 6 to the power of 2. We just need to add the indices because they do have the same base. And we get 6 to the power of 5. The same applies for B. And we just get f to the power of 5. Alright, question C, really important here that you have a think about this before you attempt it. Okay, some important things to remember here is that we've got h to the power of 4, but there's no pronumeral h in this second part of the expression. We've got g to the power of 2, we do have a g in the second part of the expression, and we've also got the k. So remembering that you can only apply the index laws to indices with the same base, so it's only going to be for g that you're going to be able to simplify it. Alright, that should have been what you got, and when you simplify that, you get h to the power of 4, g to the power of 3, f squared, and k. Alright, remembering the same thing applies for D. Okay, so making sure that we're only adding powers at the same base. And your solution should have been 2 to the power of 5, because you're adding 3 plus 2, a to the power of 4, because you've got 3 plus, and it's a to the power of 1. Remember that if there's no power there, then that means it's a to the power of 1. And p to the power of 5, because you've got 3 plus 2. Then you need to simplify that just by putting 2 to the power 5 in your calculator, and you get 32 a to the power of 4 p to the power of 5.